The University of Pennsylvania's GRASP Laboratory and Lockheed Martin's Advanced Technology Laboratories will be collaborating to field an entry in the upcoming Urban Challenge event. Our team is composed of a number of leading researchers with relevant expertise in computer vision, machine perception, machine learning, and hybrid control. Our group has a history of successful collaboration, and we have been leading performers on a number of past DARPA-funded projects. This section describes some of our prior work on developing an autonomous on- and off-road vehicle based on a GMC Canyon pickup truck. We designed and implemented systems to actuate the primary driving controls, throttle, braking, and steering using a robust decentralized controller area network, and equipped the vehicle with a GPS receiver and a pair of stereo cameras mounted on a pan-tilt head. A PC processes sensor input and issues motion directives to keep the vehicle on a predefined course while avoiding obstacles. We have demonstrated autonomous GPS waypoint navigation both in a parking lot and in a rolling meadow with critical obstacles on the vehicle's path. Principal investigators on this project have had past experience fielding successful autonomous highway vehicle systems. These systems, developed with support from the Honda Motor Company and Delphi Automotive, demonstrated real-time vision-based lane following, automated lane change maneuvers, radar-based obstacle avoidance, and adaptive cruise control. The autonomous systems developed under these programs were tested on closed tracks at speeds in excess of 75 miles per hour. The experience gained in real-time lane extraction and vision-based lateral control will be used to develop low-level lane regulation systems for this project. The Advanced Technology Laboratories at Lockheed Martin have developed advanced multi-sensor data fusion algorithms which will be used to combine measurements from multiple sources to detect static and dynamic obstacles. These systems were developed under government and Lockheed internal research and development and were demonstrated in flight tests running on Apache Longbow and Black Hawk helicopters. Penn is one of 8 performers participating in the DARPA Learning Applied to Ground Robots program, or LAGR. GRASP Lab researchers have created algorithms and software that enable the LAGR platform to build accurate maps, avoid obstacles, and plan long-range trajectories using learned visual cues. In doing so, researchers have found innovative solutions to problems including fast replanning and robust pose estimation. The LAGR software is largely vision-based. High-resolution stereo cameras capture color images which undergo real-time stereo processing to create disparity images. These are then analyzed to provide data that characterize terrain traversability. These are then used to create local maps, which are then fused to create a global navigation plan. As part of the DARPA Mars 2020 project, researchers at Penn developed autonomous ground vehicles that demonstrated autonomous GPS waypoint navigation, stereo-based obstacle avoidance, and automated trajectory generation. In addition, Penn has developed novel software architectures and development environments for high-level scripting of algorithms for perception and action. The experiences gained designing the hybrid control schemes that were used to regulate the behavior of these unmanned ground vehicles will be applied to the problem of developing hierarchical control strategies for the Urban Challenge vehicle. The Role-Based Operations Architecture, RBOA, is the top-level component of decision and control, integrating strategic planning, reasoning, and contingency management components into a single architecture. It performs game-theoretic evaluation of traffic situations using hybrid reasoning techniques to determine the most appropriate behavior with the ability to control multiple vehicles in single and team formations. MENSA is RBOA's contingency management component responsible for detecting and responding to unexpected conditions. Developed under Lockheed Martin internal research and development, the collaborative autonomy system incorporating MENSA has been successfully demonstrated by Lockheed Martin controlling a team of Silver Fox aircraft with MENSA detecting and triggering responses to conditions such as pop-up threats. MENSA also ran on Penn's Cloudbuster platform. The successful integration confirms MENSA ability to be applied to diverse platforms. The effort also demonstrates Lockheed Martin and the University of Pennsylvania's ability for successful and efficient collaboration.